Today's lesson is 1.2 mathematical patterns. So if we look at these numbers here, we need to see if we can establish a pattern. In general, when we're trying to establish a pattern, we're going to look at it as, do I add some number to get to the next one? Do I subtract some number to get to the next one? Do I multiply by some number to get to the next one? And do I divide by some number to get to the next one? That last part, with dividing, technically if we divide by something, we're multiplying by a fraction. So if I'm dividing by 4, I'm technically multiplying by 1/4. Same thing with adding and subtracting. If I have a number sequence that goes 6, 4, 2, 0, I'm subtracting 2, but I could also call that adding -2. Half dozen of one, 6 of the other. So it's basically saying that those are the same. Dividing by a number and multiplying by its a fraction is the same, and adding a negative and subtracting a number are also the same. If we look at this mathematical pattern, I need to establish what is happening between each number. So when I go from -4 to -1, I'm adding 3. When I go from -1 to 2, again, I'm adding 3. If this continues, then I know that is my pattern. Each time it goes up 3, and if I have to find the next number in the sequence, I would just add 3 to 8 to get there. What about over here? I go from -1 to 10, then from 10 to -3, then from 3 to 73. So we would need to see if a pattern is established here as well. As we look at this one, let's start by trying to add a number. I would need to add 11 to get from -1 to 10, but then 10 plus 11 does not give me -3. So we know that is not correct. It's not adding. We could try multiplying. -1 times -10. So we multiplied the first one by -10. Let's try doing 10 times -10. That would give us -100, which is not -3. So we can't multiply or add to get to this. Some numbers just are not a pattern. And that's the case with these. There's no pattern to it. There's no way to find that next number. We just have to accept that sometimes in life things aren't going to work out. Sequences may help you in the visualization and understanding of patterns. So that's what we're going to move into. A sequence is an ordered list of numbers. Each number in the list is called a term of the sequence. So if we're looking down here, this is a sequence. Each individual number is a term. So each of these creates one term of the sequence as we go up. An infinite sequence is a sequence with an infinite number of terms. So if I look at this one, it is going to go on forever. Add 2, add 2, add 2, add 2, add 2. Next one would be 14, 16, 18, 20, 22, 24, 26. You get the point, but It is an infinite sequence because there's nothing that could ever make that stop. So infinite sequences have an infinite number of terms. They'll go on forever and ever. This next one is also an infinite sequence, although we don't know exactly what's happening. We could look at this and try to figure it out. If I'm looking at the actual terms, they're going up by 2 each time. So I'm adding 2, but then if you look at it, it's a negative. So positive, negative, positive, negative, positive, negative, positive. Next one would be a negative, and it would be 15. That takes us to sequence notation. If we're going to talk about sequences, we have to have a way of writing them correctly. The following notation denotes specific terms of a sequence. The first term of a sequence is denoted U sub 1. You see, it's called U sub 1 because this little 1 is down low. It's like a submarine. Submarine goes low, so it's U sub 1. And that would be the very first term of a sequence. The second term is U sub 2. You know that notice that the only difference between this and U sub 1 is that the number changed. It's because it's the second term. The term in the nth position is called the nth term, denoted by U sub n. Why are we talking about an nth position? That just means any number I choose, so it could be U sub 20 or U sub 50. U sub n is a way of saying that some number in the sequence, it could be close, it could be off in the distance, but it's any number that I can determine. So it's like a variable where we can change it to whatever we need it to be. The term before U sub n is U sub n minus 1. In other words, the term before the term we're talking about. If I'm talking about U sub n, and I think of U sub 50 in my brain, then the term before that is U sub 40. U sub 49, sorry. So that it's U sub 50 minus 1, which is U sub 49. So the term before the 50th would be the 49th term. Works the same way with U sub n. The number that comes before it, or the term that comes before it, we would just subtract 1 to find that number. That's why it is U sub n minus 1. Example 1, terms of a sequence. Sorry about that, I had to clean that up a little bit. I've already tried to record this video once, and it got ugly. So, when we look at diagram 1, there's exactly one circle in it. When we look at diagram 2, there are 3 circles. Diagram 3 has 5 circles. Predict what the next one is going to look like. So when we do diagram 4, if I'm looking at this, it had 1 circle, then it got 2 up top. This one, diagram 3, we added 1 circle down here and 1 up top. And so if I'm looking at this, the original was 1 circle. I had 1 down here and 1 up top. Now I have 3 circles. If I look at diagram 3, I have 5 circles. I took what we just had, which would be something like this, and I added 1 to the bottom and 1 to the top. Diagram 4, I'm going to add 1 to the bottom and 1 to the top. So that if I'm now counting my circles, 1, 2, 3, 4, 5, 6, 7. So there's 7 circles. I can continue doing this. Going on forever. So the question turns into, what is happening with my pattern? I had 1, 3, 5. If I list out the terms of my sequence, sorry about that. There we go. If I list out the terms of my sequence, u sub 1 is 1. U sub 2 is 3. U sub 3 is 5. U sub 4 is 7. U sub 5 is 9. If I'm writing the sequence out, it's just 1, 3, 5, 7, 9. Dot, 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 showing that it can go on forever. The point of this being that I don't need to necessarily have the u subs. I can just know what the u sub is because it's the fourth term in the sequence is 7. We could also graph this on the coordinate plane. We can start by drawing my coordinate plane. You can tell how perfect it is. So my first term, I had 1 circle. My second term, I had 3 circles. My third term, I had 5 circles. My fourth term, I had 7 circles. In my fifth term, I had 9 circles. By graphing this out on the coordinate plane, I can come up with a line that goes on forever, and I can use that line to predict, say, what the 10th one would be like, or the 6th one. If I go over to the 6th and up to here, that's going to be my next point, which it looks like is up 2 from where we were, which is going to create a way to predict in the future based off of this line of best fit. So that would be the advantage to graphing on a coordinate plane, is that it'll allow you to predict far off into the future. Tonight for homework, I'm going to see if you can figure out some of these sequences, what the next term would be.